Okay, this is lesson 43 for 8th grade, and today we're talking about surface area. And I make a little side note here that this is different than volume. They both deal, volume deals with three-dimensional shapes, surface area does too. The only difference is volume, we try to figure out capacity, how much can be held within a certain container, where surface area we're trying to figure out what is the area of the surface or the things on the outside of that object. So here we're talking area, two-dimensional thing, volume is a three-dimensional thing, and the confusing part is we're talking two dimensions even though we're dealing with a three-dimensional object, and I'll show you what we mean when we get into this. Later on, once we get to high school, we're going to use surface area of different containers when they're open or closed, or maybe there's a top off of a certain object. Then we'd want to find the inside parts of the area too, and you'll kind of see what I'm talking about once we kind of introduce what this is. So, surface area, by definition, refers to the combined area of outer faces of a figure. Okay? So imagine taking a 3D shape and dipping it in paint. So putting the whole thing into a bucket of paint, just make sure everything is under and then bring it back up. And anything that is covered in paint after you take it out would be considered the surface of the object. So anything covered in paint is what we'd be finding the area of. Okay. For now, like I said, we're going to be dealing with closed objects, but like when we get to high school, let's say we had, let's say we just had a cylinder, and if it wasn't closed at the top, maybe it was open, the paint would get on the inside too. We would also consider that the surface area. But for now, we're going to deal with closed objects. So if we had a cylinder and we dipped it in paint, we'd be finding the area of two circles, top and the bottom, and then the cylinder part around the two bases. And what we call that is the lateral area. So the lateral surface area is the combined area of all the faces except for the base or bases. So basically, lateral surface area is area of the surface, but it leaves out your base or bases. Okay? And we actually have a formula for this, for prisms and cylinders, for those things that have two bases, basically. We take the perimeter of the base multiplied by the height of the figure. Okay? And we'll show you what that is with this example here. So just to start us off, bad mark there. We have a cube here. Remember, a cube means we have all the same side lengths. So this is 10, this is 10, and every segment's 10. Alright? So cubes are nice to work with. First, they want us to find the total surface area of the cube. Well, let's just take a look at one of these squares here. I'm going to draw it small. We have a 10 by 10. So for A, we have, if we want to find the area of just this square, area equals length times width for a square or a rectangle. So we do 10 times 10, and we get 100 centimeters squared. Okay? So we're in two dimensions. So 100 centimeters squared when we multiply two dimensions together. But what we're going to find out is that we have how many of these squares on this cube. Well, we have one here, one back here, one on this side, and then a top and a bottom. If we were to unfold this cube, it's called a net. We're going to talk about that briefly in a second. Won't be the best picture, but you should see what we're getting at here. I think that's right, yep, just like that. If we were to unfold this cube, how many squares do we have? Well, we have 1, 2, 3, 4, 5, 6. So we're going to multiply this by 6 and get our total surface area. So 600 centimeters squared. So that's our total surface area. Lateral surface area, remember, that deals with the area of just the sides, but without the bases. So we're going to take these two things out. These are our bases. So we're looking for that area, that area, that area, and that area, which would be this side. Gotta get a new marker there. And that side, plus the other two sides that we can't see. One is on the left side there, and one is in the back. But we're looking for those areas, that's how they match up. So we have 4 of those squares. And remember, we found out one of the areas of the square was 100 centimeters squared, so we'll multiply it by 4 this time. Because we only have 4 squares that we want for the lateral surface area. And we'll get 400 centimeters squared. So that's our A, that's our B right there. Okay? Alright. Now the difference between, like I mentioned, for volume and surface area. Total surface area is 600 centimeters squared. Volume yesterday for a prism was length times width times height. That tells us how many cubic centimeters are going to fit into this cube. And remember, this meant we had 10 rows here by 10 rows here, and our height was 10. So we had 10 of those things on top of each other. But really what that meant is that we could do 10 times 10 times 10, or 10 by 10 by 10. And we would get 1,000 cubic centimeters. So difference between volume and area. How much space can we fit in to that cube? What is the total area of all the faces added together? So that's the difference there. Notice 2-dimensional, 3-dimensional right there. Area is a 2-dimensional concept, volume is a 3-dimensional concept. Alright? Okay, now find we found the volume of this shape yesterday. We're not going to do it again, but we're going to find the lateral surface area of this one because we want to paint the walls of it, not the tops or the bottom. Not the top or the bottom, but we just want the lateral surface area. And remember, our lateral area is what I'll call it, LA, lateral area, is perimeter of the base times the height of our object. Okay? Height, that one's easy, that's right here. How tall is your building? 10. Height is 10 feet, okay? Our base is kind of a irregular base. That's this right here. Okay, so that's the base up that we're looking at. And if we wanted to take that, we'll try to draw this as good as I can. Let's say we wanted a top view of it, which we might want. So that would be our top view there. Okay. This side matches with this side, so 12 and 12. This side and this side, 12, 12. This side and this side go together. So this is 15. Not drawn to scale, by the way. That's my fault. This side, 20. This side would be 20. And then we got to figure out how long this side would be. That would be this top part right here. That looks like it's going to be 12 plus 15, so 27. That's this right here. 12 plus 15 to get that. And then we want this side, which is 20 plus 12, 32. So this one would be 32. And we'll just split those up. That'd be your top view there. but it kind of helps us find the perimeter. Now we can add up all of these things. We would do 32 plus 12 plus 12 plus 15 plus 20 plus 27 to figure out the perimeter. And if we add all those up, we should get 118 feet. And we said our height is 10. So 118 times 10, and we should get 1,180 feet squared. That's the lateral surface area, or at least it should be, so let's check and make sure we got that right. And we did. So cool. We've got the lateral surface area there. My battery is getting close to dying, so if that does happen, I might have to grab the other camera. I'll let you know. Alright. Once again, like I said, this is our net. This is actually a cube. If we were to unfold it, we call those nets. Okay? And they can help us visualize things a little better. So, if we wanted to estimate the surface area of this box, what I would say is, first we're going to round these things. So 7 3/4 rounds up to 8 inches. 12 1/4, that's going to stay at 12. 2 3/4, 3. Now they didn't draw this very well, but it would help to have a net for this one. So let's take a look at it. We have a top and a bottom. Something like this, I think. So top, this would be a 8 by 3. This would be a 12-inch 8 by 3. Okay? And then we've got a what? So this is an 8 by 12. Then we've got a 3 by 12, like so, and then another one of these. So this is kind of what it would look like. Not the best picture that they gave us, but we have a back, a front, a top, bottom, and let me check here. Just making sure we're on the right battery and things like that. So 8 by 3s, this is a 8 by 3. 12 by 3, that would be these pieces. And then we have two 12 by 8s, and those are these two. Okay? So 12, 3, 12, and then 12, and this is another 8. Okay? So we've got 2 of everything, basically. So if we do the total surface area, we've got 2 3 by 12, so that's 3 times 12, sorry. 3 times 12. And 3 times 12. We've got 2 8 by 3s. And then we've got 2 8 by 12s. Okay. So if we find the area of each rectangle, and then we add all those up, we should get our total surface area. So 36, 36, 24, 24, 96, 96. So if we add up all of those, we should get our total surface area in inches squared, and that would be an estimate, of course. We'll carry on with this tomorrow, and we'll see you then.